and I will hand over to David.
In this case, Dan to start.
Okay. All right. Well, yeah, good afternoon, everyone. We'll have an introduction on the next slide, but today we're going to explore Elta's role in the ventilation industry, some of our capabilities, and how smart, controllable solutions are shaping the future of air movement. We're also going to touch on regulations, different fan types, and the impact of the Internet of Things on system performance.
So with that in mind, I'm Dave Millward. I'm the product manager for Elta Group. I've been with the company for a very long time. I pretty much cover most of the UK and Ireland businesses in terms of product, with a heavy focus towards the HVAC side. And I'm joined by Dan Owen. Dan's our engineering manager for the building services sector. So he covers our King Swinford facility for engineering. We do have engineering facilities elsewhere as well. And Dan's predominantly covering our building services market, from air handling units to commercial buildings and general ventilation. So together we'll guide you through what makes Elta a key player in the ventilation market and how we interact with controls.
You're on mute, Daniel.
Apologies. Yeah, so I'm not sure how much of those in attendance know about Elta and Elta Group, but we operate across 3 continents and 7 different countries, and within that we have a portfolio of brands which cater for different areas of the market. So we're a private family-owned group, and we've been advancing ventilation technology since the 1960s, with a mission to enhance life through air. So just touching on some of those brands there, we've got in mainland Europe, we have Aurolica, who build and manufacture residential products for elsewhere in the group. We have in Australasia, Colair and Smooth Air. Colair's small air handling units, and Smooth Air, again, residential type products. And then in the UK, we'll touch on in the coming slides. Okay, so Elta as a brand, as a business, been operating since 1974, and within that time we've been designing and manufacturing ventilation solutions, with a long history reflecting deep expertise and continuous innovation in the industry. Within that we have a number of employees which have sort of a long service and a lot of experience with our industry. Okay, in the UK, as Elta, we have 5 manufacturing centres and distribution dotted around the UK, strategically located to meet our customer needs. We have a strong local supply chain, allowing us to deliver reliably from standard to completely bespoke solutions. So just touching on a couple of those locations, our plant in Fareham predominantly manufacture axial fans for bespoke applications and the more challenging environment. So these could be axial fans up to sort of 2 meter in diameter for sort of harsh, heavy industry, offshore, and those types of places. And within that, we also handle the export division, and that's at Fareham. Kings Swinford, where I'm based, in the West Midlands, we manufacture the bespoke air handling units, alongside more standardised axial and box fan products for the building services and general HVAC products. Colchester, that site is used to build attenuators and bespoke acoustic enclosures, and that could be for plant rooms and roof locations to mitigate the effect of noise generating items. And then looking to Northern Ireland, It's predominantly a distribution centre, but also has the facility to build ductwork for the local market there. And then finally, in Salisbury, they have a manufacturing setup to cater for the ventilation needs of the agricultural applications. Okay, so markets. So from commercial, industrial, and residential buildings to agriculture and OEMs, our ventilation products serve all of those range of sectors. We're involved with extreme environments, sort of offering products that cover hazardous areas, be that dust, or life safety smoke ventilation systems, such as buildings emergency smoke extract. Okay, this image sort of shows some of the products that we can offer and where they generally go within the building envelope. So we provide a comprehensive ventilation coverage from the underground car parks, which you can see, up to the rooftop extract fans. So whatever the building needs, we offer solutions for every point within the air movement chain, including the acoustics and the controls, which we'll go on to in a little while. So yeah, some of these fans here you can see on the second floor. There's the AHU there in a plant room. In the basement, there's an induction fan, which is typically used in car park applications. Through to on the roof there, we've got a prefabricated system there which would be used for the smoke extract. And these products cover a wide range of uses within the building, but then can be used elsewhere in particular applications. Okay, and then we have specialist projects. So again, as I mentioned, the bespoke axial fans are built at Fareham, and one of our core strengths is creating these customized and engineered products. These are designed for clients with unique and demanding ventilation requirements, especially for OEMs and the industrial sectors. So at each of the manufacturing locations, we have engineers that are sort of experienced with the markets that they serve and able to sort of create these bespoke customer-specific solutions for different applications. The other thing we want to cover is quality assurance within Elta is a top priority. Every manufactured product at these sites is end-of-line tested in-house before it's shipped. So it just gives us that reassurance that the fan will do what it's meant to do, and any issues have been addressed before it gets to the customer. We're committed to meeting and exceeding these global standards and certifications. And as a result, we're members of a wide range of industry bodies helping to shape the future of ventilation. Also, two of our locations in the UK, we have research and development labs. That's at Fareham and here at Kings Winford. Those are committed to working on future projects and products, testing for airflow, electrical performance, alongside sound, and providing services to clients who wish to witness test the products which we are selling to them. Okay, our products carry internationally recognized certifications, and as mentioned, we're active members of industry bodies that influence and the research, regulation, and best practices to keep us and our clients sort of ahead of the curve. More recently, we've become members of the Sustainability School, silver level there, and we're getting more and more requests for environmental documentation for our products and the supply chain behind that. The other ones to note there are eData and Lock-ins, where these are sort of central sources of product data, which is used by different parts of the industry to sort of verify and give a single source of information. So our products are listed in those places for that purpose. And then over to Dave.
So what I really wanted to point into work on it now is really the ventilate and the role of connectivity and controllability for smart ventilation. Ventilation is not just about energy efficiency needs. It's vital for comfort, health and well-being, and integration with controllability and connectivity. Those type of systems then can now adapt in real time to changing conditions, which enhance performance and simplify compliance. So improving air quality by removing pollutants, controlling temperature and humidity, and enhancing worker and occupant safety, whilst also providing condensation and structural damage under certain conditions. So we're looking at how ventilation now operates for the benefits of people and of the building fabric. And so it's very important to us of how we monitor the air and what the activities are within buildings, and then look at how ventilation can adapt to suit it. So we're not just considering from historically what's been a specific specification-driven need, where a building's designed, the ventilation specification for that building is considered. We create everything that's needed for the ventilation for that building from the beginning of that building. But as we all know, the life cycle of buildings rapidly changes. And what we tend to find now is that ventilation really is based around what the original design of the building was for, not what is actually happening in the building today. And that's where the monitoring and control and understanding of what's going on is so important. So we're looking at smart ventilation so that we can ensure optimal air quality. We want to reduce energy waste, and we want to support the building regulations that are driving through this, not only through the UK, through European and other regulatory bodies as well. So the controllability allows us to tailor solutions to every environment and use. That gives us the ability to monitor the air quality and to adjust the rate of ventilation to suit the business needs and the premises owners' requirements. The tools to ensure occupant welfare, improve productivity by reduction in lost hours. There's a high number of studies that literally have proven that poor air quality in buildings can lead to sickness within employees and then lost time within the buildings doing the work that we want them to do. So also to maintain structural integrity of the building. Well, we all know about certain pollutions that can cause damage to fabrics. We know of things like volatile organic compounds that we need to remove from the fabric of the buildings through historical design. And that's where ventilation can really be an important thing. So what we're trying to do here really is make the invisible visible. We install ventilation equipment above full ceilings, hidden away in plant rooms, and the only thing people see in buildings is a grill or a diffuser, and they don't know what actually happens. But it's bringing that to the forefront so that there's a greater understanding from both employees, the public, as to what the benefits of ventilation are and how controllability can help that. So we align ourselves with regulations. Critical ones in the UK are Part F and Part L of the building regulations. Part F covers ventilation. Part F covers targets of efficiencies. Both also indicate the need for control. And again, with those are just two UK common building regulations requirements, but we also cover regulatory needs across all continents where we're present. And what we find is using connectivity helps us to monitor and automatically adjust the rate of ventilation to remain compliant. So a critical thing here as well, I've touched on earlier, is that typically we design buildings for when they're built. What we're looking at now is how we can adjust ventilation to the actual requirements of the present day and what is actually going on into that building. And that also leads you to energy efficiency, because typically in the past, ventilation has been based on full speed operation. So you literally switch the fans on in the morning and you let them run all day at the same speed, irrelevant of what occupancy is, irrelevant of thermal conditions, irrelevant of any involvement of what the building's for. And that can be a waste of energy if the building's not being used. So that's another good positive of controllability, is allowing us to manage the amount of energy use we're using. Beyond building regulations, there is a great deal of European requirements now. Yes, I know we're not part of Europe, but the reality is nearly all our British regulations are coming out of Europe. And anybody who sits on European committees like some of us do will know that we're very active in actually updating and improving those regulations in Europe. So we're still a very strong partner in Europe about how the ventilation world is organised and goes forward. So our systems incorporate energy recovery and intelligent control. So with heat recovery, we can recover a lot of the thermal losses. We meet standards and we track efficiencies in real time. We're constantly striving through R&D, as Dan mentioned. We have 2 plants in the UK with R&D facilities where we are constantly looking for new technologies and materials to help us supply tomorrow's ventilation. And this is where, you know, if you don't know too much about Elta in the past, we're quite new members to the BCIA. And one of the main drivers for us to join the BCIA as predominantly a fan manufacturer, not a controls manufacturer, was our understanding and awareness of how important controls is to what we do as a manufacturer, and being able to be on that platform with control suppliers, so we have the same goals and the same outputs. So very simplistically, you know, controllability is not a luxury. I think in the past, you know, I've been in the ventilation industry, unfortunately showing my age, from a time where as a service engineer we didn't even have mobile phones and we had to use a phone box of a 2p coin. So we've come quite a bit of a journey in my time scale. And at one time, you know, being able to put a speed controller on a fan was considered a bit of a luxury. You can just run it at full speed, who cares? But now it's an essential requirement to be able to adjust the ventilation rate, not only for occupant comfort, but also for energy savings. And also, which is sometimes, you know, not represented, is to be able to diagnose system faults and to be able to early recognise any possibility of downtime in the future. So a core thing going forward, particularly when we look at eco-design regulations and sustainability regulations from Europe, is how we prevent downtime, how we increase serviceability, how we make it easier to replace component parts rather than whole units and whole systems. And the benefits of control is to allow us to diagnose the system. So with connectivity and IoT, we're looking at how we can monitor system performance in real time, predict maintenance needs, and integrate seamlessly with building management systems. So we're almost at the point where we're suggesting that our physical mechanical ventilation unit basically becomes a node on somebody's system, so that we can report back and tell the main building management function what's happening to the ventilation. You know, we have the facilities to monitor bearing temperatures or winding temperatures within motors that can give us an indication of what lifetime is left within the capability of the motor itself. Typically, a motor will have 50,000 working hours, which seems wonderful and very long. But if you're running 24/7, 365 days a year, 50,000 working hours soon gets eaten up. And the weakest point of a ventilation fan is the bearings of the motor. It's a rotational machine. That's where all the work is done. So being able to monitor those components within our ventilation equipment will allow us to report back to the building management system that there are things that could be happening that are going to have a consequence on the building. So we're trying to be smarter and we're trying to be a more efficient operation in a building. What we're trying to do here now is our fans and our air handling unit solutions, we're trying to bring specific benefits across multiple sectors. So we work across offices, hospitals, retail, warehousing, large industrial complexes. Apologies for coughing. The scale of that is to basically ensure we have a scalable approach irrelevant to the type of building we're working on, whether it's a small complex or a massive complex. So it's important to us to be able to have solutions that are very small. We deal in small restaurant chains where you literally have a bar, a restaurant area, a preparation room, a kitchen, and that's about it. But you can still have communication within that environment to be able to ensure that we've got the right ventilation rates, the right extract, right the way up to doing large ventilation systems across multiple large complexes that have different type of uses. The benefits are quite clear. There's a number of studies. The graph I've got, the bar chart I'm showing here is very generic. It's based on really, if we provide greatly improved efficient components within ventilation products such as EC motors, high efficiency motors that allow us to reduce energy just purely in the fact that we're using more efficient machines, but also on that the controllability of that machine only ventilating at the times we need to ventilate. If we reduce the fan speed by 5%, we'll typically get on average a 20% saving in actual power usage. So speed control is a massive part. The ability for us to improve air quality by monitoring the actual pollutants in the environment, that gives us the ability then to vary the airflow the opposite way, where we might reduce the airflow because we've got very few occupants or good quality of air, or we don't need to run the fans at full speed, we'll reduce the fans down. But the opposite scenario is we've now designed a building in its original spec. I'll use numbers that maybe not common to a lot of people, but you can use things like 15 litres per second per person to give you a flow rate within a room. So if you've got 10 people expected in design of that room for a meeting, then you need 10 times 15, you need 150 litres per second of airflow. The reality is that room could end up being used for anything. Take the tables out, we could have a Zumba class, there's 20 people in there dancing. 150 litres per second isn't going to be enough for that environment. So being able to have speed control and change of the ventilation rate through monitoring the air quality, we could actually increase the airflow. And on the basis of that, we're then talking about cost effectiveness. So we're not only talking about the cost of the equipment, there's obviously capital expense. And unfortunately, we still live in a world where front-end capital expense is pretty much the key requirement of procurement people. But if you look at the life cycle of the product and the building, by having more advanced equipment with better monitoring, better controllability, the likelihood is that the building environment will have far greater cost savings in terms of people's welfare and people being in the building and doing the work, being more efficient, having less cost after capital cost. The running costs are going to be lower. So there's a number of areas that controllability can massively improve how we work and how we operate within buildings. Barriers exist, as I have just said. A critical adoption challenge to us is usually the initial cost, You know, we've gone through a great scenario through predominantly the initial requirements of eco design from 2011, 2015, 2018, and again from next year, where we're having to manufacture ventilation equipment at a much greater energy efficiency value, which means we're not using so much energy. In doing that, we've had to adopt improved technologies. So we've moved away from a lot of instances where we're using old school AC foot mounted motors that have been the backbone of industry for 50, 60, 70 years. And we're using higher efficiency motors, permanent magnet motors, electronic commutation. All these initially come at a higher investment cost. The difference being is, and where we've done a lot of training and work with our customer base, is if you take an AC basic motor that may be 60% of the cost of an EC motor, for an example, the AC motor will then need additional controls to allow controllability. So we might be buying an inverter, we might be buying a voltage controller. While typically an electronic commutation motor has all those controls built in. It pretty much, simplistic terms, has the inverter built into the motor. So you're now not buying secondary equipment on the back of the motor, it's all provided it within it. So although initially the cost looks more expensive, when you add all the components together, the more efficient version often costs less. Integration and security, I think this is the biggest area that we need to break down barriers. We typically see this in a lot of businesses we work with, where the biggest concern is not from the ventilation side, it's from the security aspect of the building management team, the admin team, for instance, that is looking at, well, if you can interconnect our ventilation equipment outside the premises, is my data protected? Am I safe? Am I at risk from other people being able to access and adjust the ventilation? So security and privacy, which I'm talking a little bit out of kilter, it's not really ventilation. I know there's going to be building management system guys on here who know far more about this side than me. It's still the biggest concern that we come across when we go to people with ventilation that can, if set up correctly through a building management system, pass that detail out through the cloud for it to be monitored. And it is a driving force going forward. We see a situation, not in the too near distant future, where you could see ventilation equipment not being paid for and supplied as a one-off purchase, but more as a sort of rental sort of idea, where your ventilation system in a building is controlled and supported by the manufacturing facility, can monitor it, see when maintenance is required, see when upgrades are required because the building's being changed to using a different format, improving with more modern equipment, improving with better sustainability equipment. And we foresee a time where we will manage equipment more than actually just sell it. So it is becoming more affordable, as I mentioned with EC motors. When you start to build the picture of controls and fans together, that actual initial purchase cost is actually lower than what people think. With the requirements of European legislation in terms of digital passports coming forward for products, we are getting to a more secure environment, and we can be compatible with existing systems. It's not you need to start from scratch scenario. You can build up on what's already there and start to plan for a better future for the building. So I'll stop talking for a little bit and leave it to Dan to talk a bit more about how we do selection.
Yeah, thank you, Dave. So again, not knowing how many of you are involved with selecting mechanical equipment or particularly around ventilation, but within Elta we have two main selection tools, one for our axial fans and standard HVAC box fans. The other is for our bespoke air handling units. But in both instances, our selection process starts with an understanding of the physical requirements of a space, And from there, we choose systems to match the air movement and pressure needs precisely. Usually we start with an airflow requirement, which is measured in cubic meters per hour or cubic meters per second. And this is in requirements based on room size, expected occupancy, or room use for that space, and any air change rates that are dictated in the building regulations or other regulations. Alongside the volume requirement, then you need to overcome a pressure, which is generally as a result of the ductwork system. So any lengths of ductwork, transitions, grills, filters, all those system components create a pressure drop that you need to overcome. So you start with your airflow and your pressure, and then you need to look at sort of the type of ventilation system. So are we just supplying into that space fresh air to dilute any pollutants already inside, or are we looking to just provide exhaust ventilation to remove stale air, or in the case of an emergency, sort of remove the smoke and other gases? And then it could be a mixture of the both. So we're looking to supply fresh air and have a balanced ventilation system, so we're supplying and exhausting at a similar rate. Other considerations, particularly on the air handling side, is around filtration and the required air quality for that for the area that's serving. So in hospitals, it could be sort of HEPA filters or UV sterilization to eliminate bacteria and viruses, and also ensure sort of air quality standards for those applications. In other areas such as takeaways and restaurants, it could be sort of carbon filtration to reduce the odors from cooking fumes, particularly if you're discharging to outside and you've got a residential area or in the street, and you want to make sure that the local residents are not impacted by your operations. You also need to look at energy efficiency and how important the power consumption is to the client. So we use the term specific fan powers. That's the amount of energy per litre per second that's being absorbed by the ventilation system. So again, there's requirements within the building regulations to be within certain limits for different applications, but customers may have their own requirements on top of this. The other, as Dave mentioned, is the other factors are the type of motor technology suited for the product, whether that's EC motors or an AC motor with an inverter controller, as an example. And then whether or not we're looking to recover energy that's already in the space. So again, in the case of air handling units, or MVHRs, we could be looking to take the air from within a space and use that to temper the incoming air, so we're not having to use as much energy to heat, add preheat to that incoming air. Other factors are sort of noise, whether that's important to the customer. Again, it could be serving either a residential home or a school, as an example, and there you don't want the ventilation system to be causing disruption to those areas. So we can look at different products with insulation materials to prevent the breakout noise from the product, or you can look at attenuation within the ductwork system to remove some of the air noise sort of as a result of the air. The other thing alongside this is compliance and regulations. So again, we serve a number of different countries and offer different products for each, but some areas will have certain requirements for CE marking or UKCA, or if you look at the Gulf region, they have their own sort of Gulf mark certification. So again, we can tailor products to best suit the environment that they're going to. And then as Dave touched on earlier, we're getting a lot of buildings where they're intended for, well, they were built for a particular use, but then things change and the standards that you have to meet also changes. So we could be looking at applications where we're retrofitting products, replacing old technology, old fans or reworking air handling units. And so this stipulation could be around getting a replacement unit into a space, which could be problematic or challenging. Or on the flip side, if it's a new build, the space may not be so much of an issue, but you need to consider future maintainability needs. And for things such as filter replacement or the servicing of motors for bearings or troubleshooting issues with smart controls. And then above all this, there's ultimately there's cost. So selection of the most cost-effective unit for the client's application, including initial capital cost, as Dave touched on, and also ongoing running cost over its lifetime. So this slide just goes over some of our current control solutions, and within our range we have we offer all of these types of products, which we currently source from our trusted suppliers, and increasingly through our own development as well. So we're transitioning from older, less flexible control methods such as transformers and electronic control to more modern sensor-led systems that respond in real time to environmental inputs such as sensors for CO2 or humidity or temperature. Okay, so legislative challenges. Air movement is subject to extensive regulation, as touched upon earlier. Our goal is to make it easy for our clients to meet these standards through tested and certified solutions. So we'll just go through some examples of present and future legislation. So we've got the UK building regulations, which Dave covered earlier. UK product safety and metrology regulations. So that's coming to force to continue recognition of EU directives, including the CE marking scheme. We've got the Eco Design for Sustainable Products Regulation, or ESPR, and as we mentioned earlier, that's becoming more prevalent in some of the requests we're getting from clients for traceability of components and our supply chain. And then the next tier of our ERP, Energy Related Products Directive, which is now coming into force July 2026. So our product management and engineering teams are actively developing our product ranges to make sure that we meet these higher efficiency requirements. Over to you, Dave.
So really just to summarize what we've been talking about is that the future of ventilation is smarter and more sustainable. We're encouraging the embracing of smart technologies and partnering with industry leaders like Elta to drive innovation in building ventilation. There's a long way to go. A big problem we have as a ventilation manufacturer, in a simple term, is the item that moves the air is quite inert. It's usually just a metal, plastic, composite component. It's the driver that provides the energy, which is a motor. We're not motor manufacturers. We have some motors within our portfolio that we do own and produce ourselves. But when you're trying to cover ventilation needs from a residential toilet extract to an oil and gas hazardous machine at 2 meters, you're not going to be able to cover all those motor requirements. We have fire safety motors, we have hazardous motors for ATEX, we have induction motors, we have permanent magnet motors, EC motors, shaded pole motors, AC, capacitor run motors. The reality is they all need to communicate in a similar vein for us to be able to communicate all our equipment in a similar platform that users can understand. And what we're typically finding is most manufacturers run off and do their own thing, and then somebody somewhere has to drag it all together and give us a human interface that is understandable for everybody to see. And those are the areas that we're working on and encouraging our supply chain to work with us on, is to overcome those difficulties. And there are things that, we would like to see greater recognition for the public. A big phrase I use is making the invisible visible. If you look at hygiene and food, for instance, you can look at restaurants and see whether they've got a 5-star rating or a 1-star rating. It would be wonderful from a ventilation point of view if you were to walk up to a commercial premises even and see on the door what its ventilation rating was between a 5 and a 1-star. How well, if I go and visit premises, how well is that business that I'm visiting looking after my health and well-being from the ventilation and the air quality that they're providing me? Having recognition of that, I think would be a big step. But that's really where we sit. We're on a journey. We're moving away from old technologies. What people just, as Dan mentioned, just want a nice big transformer on a wall with 5 steps on it that speed it up and down. Unfortunately, it's still a very big market, and a lot of people are only interested in doing that. But the real future is it being more automated and ensuring that you get the right welfare, and you're providing benefits for the fabric of the building as well. It's not just about people. From our business, it's about people, animals and buildings. It's welfare of animals as well as people. We have a big agricultural section, and we're working on those sectors as well. So that's pretty much us, guys, and really thank you for your time today. We are quite new members to the BCIA, and we're finding our ground within the organisation. I sit on a number of groups within FETA, and to give a bit of support to Catherine on the good work that they do, the BCIA is far more advanced and inclusive than a lot of the other parts of the associations that I work with. So it's been a fantastic journey for us so far, and we hope to continue and get greater support and help you guys as well. So over to any questions and answers, really, any queries you've got.
Any questions? Any thoughts about what you heard, or did it answer what you'd hoped to when you joined the call?
I haven't got any questions as such, but I'm really encouraged to see your open mind about the IoT of things in ventilation, because my role in Siemens has been trying to convince manufacturers like yourselves to consider digitalization, and it's been a struggle, I'll be honest. A lot of companies are just not thinking in this manner. So it's refreshing to see.
I think you're hit with two core issues, and I see it as at a level as well. Our chairman is very intent on enhancing life through air and ensuring that we're doing the right thing, and we're not just selling goods. We're making a difference to the environment and the cultures we live in. The reality of what you get, even with that, if you are pushing that message, there's a cost restraint on everything, and we all know that not that many people have got that much money handed around at the time. So anytime you try and bring something new to the table, or it sounds different, because I'm getting old. Some of the guys, we've got Emily in our marketing department. They're on a level way beyond what I was at their age. Technology is just moving so quick that I think it scares a lot of people who unfortunately are the decision makers. We almost need to flip it around where some of our younger generation actually get more integrated in the decision making, rather than us old school old boys who don't quite understand what's going on.
And we're
So
a bit risk averse as well as you get older.
absolutely, yeah, and I think it's a classic thing. I mean, product management is about that. What's the risk and what's the probability? So if you can convince the product manager that it's low risk and there's little probability of anything bad happening, then you get a tick. So I think we need to be pushing along those sort of lines a lot more, that digitalization actually improves people's welfare and actually will improve businesses. They'll have better understanding of what's going on. They'll have better understanding of what's needed. But I've worked in monitoring air for quite a while now. The first thing you have to do with any quality monitor that you use is allow the screen to be blank, because the first thing you get when you're dealing with big organizations is, but if the air quality is really bad and our staff see it, it's going to cause us problems.
That's true.
So you've got to allow time for people to get things right as well.
Yeah, no, I agree.
Right,
No,
thank
interesting.
you. Jason, when you first joined the call, you sort of mentioned what you'd hope to get out of it. Have you got any questions or gaps in that knowledge?
There wasn't a great deal about the controls as such for it. I know we have touched on it, but it was a lot about the mechanical side of the fans and stuff like that.
I would completely and utterly agree with you on that. And I'll be absolutely honest and truthful. Part of our requirement to join in the BCIA is we are a mechanical ventilation manufacturer. However, we massively understand that digitalization and where we're going is a massive important part of it. So we predominantly, I would say now, are in our industrial commercial world, are pretty much focused on inverter driven AC motors. In the light commercial world, sort of like the smaller end of ventilation flow rates, sort of like the sort of things you'd see above a full ceiling, we're pretty much using electronic commutation with external rotor motors. So we've got two main core controls methods. One is we're heavily lean towards 0 to 10 volt control, which isn't fantastic. We're limited then to what we can do in terms of, we still get voltage drops and issues with cabling. I would say in the last 2 to 3 years, we've moved heavily towards Modbus. And having got ourselves to understand Modbus to a great point of view, I think commercially BACnet is becoming more of a requirement. So we're using inverters a great deal where we're using BACnet and Modbus. And on the back of that, really, then we're starting to use a lot more PLCs, the likes of Siemens, Corel, those sort of Schneider, those sort of organizations. And our difficulty as a mechanical ventilation manufacturer, as I said about the prime mover, about the motor, is we probably have 15 to 20 suppliers to us of motors who all do their own thing and all have their own communication methods. We then have to put it into another box to be able to feed them all back to the same thing to give the same sort of signal out no matter what the fan is. And then we're starting to add cost. So a lot of my thought process from a product management point of view is to try and turn our fan into a node, so that we've got a simplistic communication tool that can literally tell you what the fan speed is, allow you to control the fan speed, give a signal back of to what capability and what it's doing and what you want it to do. So remote on off, remote failure, remote run. Those are really where our core are. We're moving from a very manual world in ventilation to slightly automated, to fully automated, and we're not, again, the reason for being part of the BCIA. I think you were quite right earlier when you said about manufacturing, and it's hard to break into manufacturing and get them to understand. The conversation is a two-way street. We need you guys to understand how our product can communicate with you. We are metal mechanical people. We need to understand better what you need from us for our product to communicate better on your systems. But at this moment in time, we are predominantly AC or EC driven with inverters or electronic commutation from the likes of Zillarbeg and EBM Pabst and people like that.
Yeah, we're finding a lot. We're controlling a lot of NVHR stuff now through the BACnet.
Yeah.
So basically, they're putting a controller on the side of their units, and then we're talking to that unit.
A difficult part of that from our side of view is we could also be treading on other people's toes. So by creating our own controls platform, when you've already got it, you just want our equipment to give you the outputs and the inputs for the building management system to do it. A lot of the time, we get asked for product that has no controls because somebody else is going to do the controls. So as long as we've just got a line of terminals, they're quite happy with that. It's ensuring we get the right balance between offering a system, offering a controls platform, and offering the capability to talk to somebody else's controls platform.
It's nice for us sometimes that you guys, you know what you're doing with the air, so you control it how you need to control it because you know all about it, and we just communicate with it in the way, we need to turn it off, turn it on, slow it down, monitor CO2s and whatever. That seems to be the easiest way for us as the controls industry to work with you guys, rather than us trying to do the whole lot. When all the volumes and whatever that
I would be absolutely on the same page. It's really a working relationship of the two sides working together for the best solution, rather than trying to do each other's jobs. We're good at ventilation, others are better at controls. Rather than us going out there and trying to be a controls expert, we'd rather come to the table as a ventilation expert and work together.
Yeah, that's fair enough. And that's why you liaise with the OEMs, don't you, to get the right controllers into your units, i.e. the Siemens.
Absolutely.
And Johnson's or whatever they're putting in there. And that's then where we communicate with them. So that's got to be very open for us to, get the BACnet onto it and pull the information back. So
we have done some very large projects where we've had a specification for controls, and part of our problem as a business in the past is, rather than just going, this is our controls platform, this is what it does, we typically say, what do you want? So we've had a couple of scenarios where we had a specification, we said, okay, that's the specification, but what do you want? And luckily in that scenario, they involved the BMS control people. So we ended up, and to me it's the right way to do it, we ended up with the consultant, the contractor, the fan manufacturer, and the BMS integrator all working together of what the solution was required for the building. And we Dan worked on this one project. We ended up with a ventilation controller that literally had space within the control to do the lighting and other things that got nothing to do with us, but it just meant that they could just have one control box.
Yeah, and that
so
we had this scenario. Yeah, we just had this scenario where we were limited on wireways because it was a refit. So the best option to us was obviously just to whiz a BACnet MSTP around the building. But then it was limited on what the controller could accept. So we were trying to put the sensors and that for the whole building into the local controllers, so we could drag the information back. But the controllers just didn't want to do it. So had they gone through your scenario like you done there, that would have changed the job completely, made our lives a lot easier to get all the relevant information back into the BMS for us to control it better, So there's definitely scope for that out there. And I wish it would happen more, let's say.
Absolutely. We're in exactly the same scenario. because the opposite end of it is we get our ventilation on site sometimes, and then they go, "Oh, it doesn't do what we wanted it to do." Okay, well, yeah, the ventilation does what it does. It's just you haven't got the communication you wanted because you haven't explained or put down what you needed.
Yeah.
So it's a collaborative working approach is needed going forward.
Yeah, that would be nice. Okay, yeah, I'm done otherwise. Thank you.
Great. Okay, well, thank you very much for joining us, and thanks to Daniel and David for hosting this short session. We do have them every month, 12 o'clock, the last Friday of the month. So take a look on the members portal and you'll see, I think the next one is with Crane BSU. So do take a look at them and join us where you possibly can. But for now, thank you very much for joining, and enjoy your weekend.
Thank you,
Thanks for your
guys.
time, everyone.
Thank you.
Thanks all for joining.
Bye-bye.
Cheers. Bye now.
Cheers. Thanks a lot.